We are on lesson 1 of chapter 7, which is exponent properties involving products. We're going to apply the three properties of exponent products. We're going to use all three properties in the same problem. Then we're going to do a real-world problem. Here are two of the properties that we're going to work with most extensively. The product of powers property works like this. Remember, product means to multiply. If we have a squared, which is a times a, and we multiply that times a to the third, which is a times a, if you lay this out here and realize what you're multiplying a times itself 5 times, which turns into a to the fifth. So the property behind this is when you multiply powers that have the same base, you just add their exponents, and that's what your new power is going to be. So we had 2 plus 3 equals 5. When you do a power of a power property, on the other hand, let's say we have a to the third, so a times a times itself 4 times because it's to the fourth power. So a to the third to the fourth power. So a times a times itself 4 times. If you lay that all out, you can count all the a's up. That would give you 12 a's, so a to the 12th. What you'll notice here is when you raise a power to a power, you multiply the powers together. 3 times 4 equals 12. So let's put this to use. It says use the product of powers property to solve. So we have 9 by itself, which means it's 9 to the 1 if you need that ever. So 9 to the 1 times 9 to the 8th times 9 to the 2nd. So the product of powers property tells us to add these together. So 1 plus 8 plus 2 would be 9 plus 2 is 11. So 9 to the 11th power. Now we have negative 5 to the first power times negative 5 to the 6th power. Keep the base the same, which is negative 5, and it'll give us negative 5 to the 7th power. Now we'll use the power of the power property to solve. We have negative 6 to the second to the 5th. So keeping the base the same, we're going to multiply the 2 and the 5 together to give us negative 6 to the 10th power. Now we have y plus 2 to the 6th to the 2nd. Here is our base because this is all to the 6th power. So we actually keep the y plus 2 the same in this situation. 6 and 2 get multiplied. So in parentheses I have y plus 2 still. Then outside it's going to be to the 12th power. This is the property I did not mention on that first screen. It's the power of a product property. And this works very similarly to the distributive property for multiplication. I could distribute this power of 8 to both numbers in this parentheses, and that would be the answer. So it would be 24th to the 8th times 18 to the 8th. Let's try that for this one then. We have negative 4z, negative 4 times z. So I can distribute this 2 to the negative 4 and the 2 to the z. So I have negative 4 to the second times z to the second. If I was going to simplify this even more, just make sure that's parentheses, this negative 4 to the second would become negative 4 times negative 4, so positive 16. And then the z squared I can't simplify if I don't know what z is, so I could have 16 times z squared. And that would be my answer. This is very similar to this one, but notice the negative is on the outside of the parentheses, and that's going to change this. We distribute the 2 to the 4 and the 2 to the z, so we have 4 squared, parentheses, times z squared. So inside the parentheses I have 4 squared, which is 16, and then z squared. And since the negative is on the outside of the parentheses, that wasn't affected by the power like it was here. So this actually stays negative, negative 16z squared. So that negative being on the outside of the parentheses really changed the outcome. Now we're going to use all three properties in the same problem. So it tells us to simplify 2x to the third to the second times x to the fourth. Well, first we can do the power of a product by doing the distributive property in a way. We can do 2 to the second times x to the sixth times x to the fourth. 2 to the second is going to give me 4, And then x to the 6th times x to the 4th, we can add those exponents, which would give us x to the 10th. So our answer here would then be 4x to the 10th. Let's do a real-world problem. It says in 2003, the U.S. Department of Agriculture, the USDA, collected data on about 10 to the 3rd honeybee colonies. There are about 10 to the 4th bees in an average colony during honey production season. About how many bees were in the USDA study? So if there's this many honeybee colonies and in each one there's 10 to the 4th, what kind of problem would that be? Well, if there's 10 classes and there's 30 students per class, you would do 10 times 30. And that's what we're going to do for these bees as well. 10 to the 3rd colonies times 10 to the 4th bees per colony. And we see that this is a product of powers property. So we do 10 to the 3rd times 10 to the 4th, which would be 3 plus 4 here for the powers. That's going to be 10 to the 7th bees. If you'd actually multiply that out, that would be 10 million bees.